the next question. We're still on the Bernoulli differential equation. Use the method of Bernoulli equation to solve question 21 to 28. I think I've done 21, I've done 23 also. Okay, so straight to this question. Okay, so if you look at this now, correspond the problem, correspond the given problem, correspond the given problem to the standard form, to dy dx plus p of x y equal to what? Q of x y n. So we correspond that. This is the Bernoulli equation. Then divide the given problem, divide the given question, by what? By y3, y to the power 3. This one. Since we said that the n must not be 0 or 1, so divide by y3. So once we've done that, then we have y minus 3 dy dx, okay, followed by minus y minus 3, this one, over y3, okay, and then equal to what? E2x, okay. So we now have y to the power minus 3 dy dx equal to minus y minus 2 equal to e2x, okay. Then the next thing to do is to do the substitution. Let v be equal to y minus 2. Then differentiate this one implicitly. So we have dv dx equal to, this one will come to the minus 2, will go to the front, okay. Then the power minus 1, that's minus 3. Then the y dx. We call this one equations, call this star 2, double star. Call this one star 1, okay. This one star 1. So what I'm going to do now, I want to correspond the double star, this equation, with this one now. You can see that this is here, okay. It's also here too. But there's a little difference. There's a minus 2 here, which is not here. So I'm going to introduce minus 2 to this equation, to this one here. I'm going to introduce times minus 2. So I'm going to call the equation 1. So equation 1 times 2. Equation 1 multiplied by what? Multiply by minus 2. So equation 1 multiplied by minus 2. So we now have minus 2 y minus 3 dy dx. Then this one also, minus times minus, that's plus 2 y minus 2. Then equal to what? Minus what? Minus 2 e2x. So so that's that. And let me quickly recap. So what I did is that from here, there is minus 2 here. Okay, I want to make that minus 2 to be here too. So I have to multiply this equation by minus 2. And that's what I've done there. So minus 2 times this one times minus 2. I have plus 2 y to power minus 2. Then this one also times minus 2. I have this. Okay. So then substitution now. So that's what we have. So equation 1 has now become this. So this is our new equation. You can call it equation 2. So I'll be making reference to this. And I will substitute all the parameters I have into this place. Equation double star, I'll put it here. Equation star 1, I'll also put it here. So combine star 1, star 2 into what? Into equation 2. Okay? And that will be equal to what? Don't forget, before I go, this one is what? Is the v dx. So that will be equal to the v dx. Once you plug in your star 1, star 2 into equation 2, then you have here the v dx. That's the v dx. Then plus 2, y to power minus 2. That's a v. Okay. Then equal to what? Equal to minus 2 e2x. Okay, so this is now what? This is now linear. This is linear. This is linear in what? In V. That's linear in V. Then we solve it in a linear differential equation method. So where P of x is got what? The P of x is what? Is 2. Okay? And when we say something is linear in certain variable, that variable must be here. That variable also must be here too. So then integral factor, that will be equal to what? That will be equal to E. That's the formula. I'll just go straight. P of x dx, and that will be equal to E. My P of x is what? 2 dx. And that will give me, this 2 is just a constant. You can go outside the integration. You're only integrating dx. And when you integrate the x, it will give you what? X. So that will be equal to what? That will be equal to E, E2x. Okay, that's my integral factor. So the general solution will now become, it's linear in V, so the general solution must be written in V. And that will be equal to what? 1 over integral factor, which is what? E2x. And then open bracket, integral factor times the Q of x. My Q of x is what? This is my Q of x. That's my Q of x. That's minus 2 e2x. Okay? Then plus what? Plus c. Okay? So that's that on that equation. Then we now have v equal to e minus 2x. If you remove this 1 over, so that becomes e minus 2x. That will be equal to bracket integral of e. This minus can come outside the integration. So that will be minus e2x, that will be what? E to the power 4x. The 2 can go outside. That's minus 2 outside. And then dx plus c. Okay? So that's what we have there. Then we can do the integration. That will be e2x, v equal to e2x, v equal to e to power minus 2x. Then we have open bracket here. Integrate this one, that will be e4x over what? Over 4. When you integrate the exponential, you must divide by what? By the derivative of the power. Okay? And don't forget your minus 2 outside. Minus 2 outside, plus what? Plus c. So that finishes the work. I just need to do little algebra. Then don't forget your v has a value. We call v, where is the equation? Where is it? I've cleaned it. I think v is what? 1 minute. V is y minus 2. Okay? So that will be equal to 1 over y to the power 2 equal to. Can we open this one? Open this bracket. 2 here 1, 2 here 2. So that's 1 over 2. So minus 1 over 2. Minus 1 over 2. Combine the exponential together. That will give you e2x. 4x minus 2x. That's 2x. Okay? E to the power 2x. Then plus c e minus 2x. Okay? Can we take the inverse of both sides if you want to? You can leave it this way, but let's finish it up. Take the inverse of both sides. So we have y squared equal to 1 over 2 e2x minus 1 over 2 e2x plus c minus 2x. The bracket what? Minus 1. Okay? Then you can take the square root of both sides, but we don't need all to. We don't need to go far. Just stop that way. So that's the end of that question. That's the end of that question.